Now let's watch some video and see if you can recognize the type of internal force failure in the video. For example, a video over here show a testing on a shear beam. So I will apply too low on the beam. And then you have the collapse. Now let's watch closely to the collapse. So this one happened very quickly. I want you to pause the video and then think about what type of internal forces that is failure in this case. Well, the correct answer is the shear force is the one that is failure in this case. How do I know that? First of all, shear force failure is something that happened very fast, suddenly, and there's no cracking, there's no bending at all, and usually that one is unpredictable. That one it happened very quickly, so it is a shear force. And also, if you take a look on the video, you will see that there is the diagonal cut in the beam that is usually due to the shear force. You can take a look on some of the other photo over here show the failure of the shear force. You're gonna see that the like a slope diagonal damage on the beam, that is the indication of the shear failure. Now let's take a look on this video. Watch the video and let me know what kind of internal force failures in this case, what kind of structural failure in this case. I want you to pay attention to the bottom of the beam. Now let's watch closely. So you can see that there is a crack that slowly build up in the bottom of the beam. That is the indication of the bending failure. Bending failure is different from a shear failure. It will have some warning signs such as a crack, and it have time to develop the failure. So usually this type of failure is less dangerous than the shear failure, because this one will bend down. So you can see the cracking is on the bottom. However, if we bend the beam up, you're gonna see some crack on the top of the beam. Let's take a look on some of the photo over here. It's also show the bending failure. As you can see over here, we have some crack on build up on the bottom of the beam, and is the indication of the bending failure. Now let's watch the video over here and let me know what kind of structural failure is shown in this video. I want you to think a little bit. And based on what we see over here, this is the buckling failure. Here is another photo that show the example of buckling failure. It usually happen in the column. It can also happen in the beam as well. We call that one is the lateral buckling. However, most of the time it happen mainly on the column. Now let's take a look on this video. What kind of structural failure do you think that happened for the beam over here? Well, you see this one is twisting, right? When it's bending down, it's not only bend down, but it's twisting. So the correct answer in this case is more of a torsion failure. If you see another video over here, you can see that the failure of this structure over here is also the torsion as well. You can see that the beam is being twisted, so it's lose the ability to carry the structure. Now let's take a look on the photo over here. What kind of structural failure do you think that apply for this photo? After you think a little bit, you can see that the column over here is being compressed, pushing is being compressed down, and there's no bending, there's no shear cut over here. So the column over here, the structural failure is compression. Here's another photo that shows the structural failure for compression. You can see this one is just it just inflate out, and there's no bending at all. Now let's discuss about the distribution of load. If you have one single point load applied to the beam over here, we call that one is concentrated load. The concentrated load over here usually apply for column. When we have the load from the beam transferred to the column, the load applied to the column usually is concentrated load. And then we have the distributed load. Distributed load is we have two types of distributed load. We have uniform and non-uniform. The shape you can see over here. We can learn more about this one in the shear and bending moment diagram. But basically, just remember for me that distributed load is usually the load we see in a beam. And then you have the surface load. Surface load is the load applied to an area. You're gonna see this one is the when we do the calculation for the slab. All right, so you have over here concentrated load is just pound. Distributed load is pound over feet, which means pound over a line, a load applied to a line. This one a load applied to a point, a load applied to a line, a load applied to an area. And now you have the volume load, which means a load applied to a volume. This kind of load usually we calculate that when you take the class in temporary structure with me. We use that to calculate the hydraulic pressures. And then you have the load or the force multiplied by a distance. You're gonna have a moment. That is a special kind of load. That is a load rotate around a point. All right, so let's review again one more time. Concentrated load is a load applied to a point. Distributed load is the load applied to a line. Surface load is a load applied to an area. Volume load is a load applied to a volume. And moment is a load rotate around a point. Concentrated load over here we apply for column. Distributed load we apply for beam. And surface load over here we apply for a slab. Column, beam, slab, column, beam, slab. Now let's discuss about the load path. What does it mean? The load path is the path that loads will transfer from the starting point. Usually you can see the slab over here. So the slab will receive all the load, such as the load of material or people standing on the floor over here. And then it will transfer the load to the beam. The beam is the one that will hold the slab. And then the beam will transfer the load to a column. The column is the one that will hold the beam. And then the column will transfer the load to the footing or the foundation. And then the foundation will transfer the load to the ground. Okay? So you see that the beam will hold the slab, column will hold the beam, the footing will hold the column, and the soil or the ground will hold the footing. The slab will hold people or material. So now review one more time. We have the load part is that the load which transfers from the slab to the beam, from the beam to the column, from the column to the footing, and footing to the ground. The slide over here can also be found in the reference on Canvas as well. The concept of this one is similar to the previous slide. However, one thing, very important thing I want you to pay attention over here. The beam will receive the load from its own slab. So for example, the beam on the third floor over here will receive only the load from people working in the third floor over here. It doesn't have anything to do with the fourth floor or the second floor over here. However, the column will receive the combination of all of the beam and slab above it. So you see over here, column will receive the load from all above it. For example, the column in the first floor over here will receive the load transfer from the slab of the first floor, the second floor, the third floor, and then the fourth floor. So that's why usually when you work in a multi-story building, you're gonna see that the column on the first floor usually very big, and then the column on the top floor usually will be smaller, go all the way to the top. However, for the beam, they usually have the same size. The beam on the first floor and the beam on the top floor usually doesn't have much different on the size. As long as they have the same span, the same length, they carry the same load, they usually have the same size. So just remember one more time for me, the beam will receive the load from its own slab, and the column will receive the load from all above floor. We will do more practice on the worksheet, and I will remind you again one more time.